Welcome to math. This is lesson 5.9. We've been looking at multi-digit multiplication and word problems. And today we're looking at word problems that will have too much or too little information in order for us to solve. So our objective today is to determine what information is actually needed in order to solve the problem and then not be distracted by any extra information. So let's take a look at this problem and see if we can figure out what we actually need to know here. Mrs. Sanchez is putting a border around her garden. Her garden is a rectangle with the dimensions 12 feet by 18 feet. So I'm just going to label that right now. The border material costs $3 per foot. How many feet of border material is needed? Okay, so I'm going to do cubes with this. So I'm going to go ahead and circle the numbers. And from there we can determine what we actually need to know for the problem. And I'll underline the question, so that will help us. How many feet of border material is needed? Okay, so it's asking how many feet. I'm looking at my numbers here and I see 12 feet by 18 feet, but I do not see a need for us to know what it costs. It's not asking for how much it's going to cost, so we will not need to know $3 per foot for this particular question. So that would be the extra numerical information that they're talking about here. It's asking us to then solve the problem. And I'm going back again to look how many feet of border. So border here seems like the key word I'm looking at. If I'm doing a border around the garden, that means I've got to go all the way around, something like a fence. And that tells me perimeter. In order to find the perimeter, to go all the way around the garden here, I need to add my dimensions together. So I can go ahead and figure that out. I would off to the side. Maybe I already know that 18 and 18 together is 36, and 24 and 24 together is, 12 and 12 together is 24. So maybe now I'm thinking about 36. It's not very helpful. 36 plus 24 feet equals, and maybe I can do a number line, do some mental math, thinking about where number talks, or of course I can write it up and down. Looking at it right now, I see that I can group 6 and 4 ones together to make a 10. So I would go ahead and do that. And I have 3 10s plus 2 10s is 5 10s plus the one I grouped together. I'm left with 60. Looking back at my question for my label, how many feet of border material is needed? I'm going to label it 60 feet. All right, let's move on. Adrian has been playing the piano for 3 years. He practices 20 minutes a day. He is preparing for a recital that is 9 days away. How many minutes of practice will he do before the recital? All right, doing cubes. I'm circling my numbers. Okay, I've got 3 years, 20 minutes, 9 days. I'll go ahead and underline here. My question, how many minutes of practice will he do before the recital? Okay, so it's asking me about minutes. I do have 3 units of time here. I have years, minutes, and days. So let's see, if it's 9 days away, we probably don't need to know how many years he's been practicing. Years are obviously longer than days, so that's not going to help us with how many minutes of practice he will do before the recital. So what I'm left with is my 20 minutes and 9 days. Since we're looking for minutes, I'm going to go ahead and box that in. Hopefully then this becomes mental math. And we're doing 20 minutes every day. Multiply that by 9, because we're doing that 9 times, or I should say Adrian is doing that 9 times. And again, mental math, I can go ahead and imagine, well, if it was 2 times 9, I would have 18. Since it's 20, I'm going to go ahead and add a 0 at the end of that. Looking back at my question, how many minutes? I will label my answer minutes, 180 minutes. Here it says the campers and staff of a day camp are going to an amusement park on a bus. Each bus holds 26 people. How many buses will be needed? Then it's asking us, do you have enough information to solve the problem? What additional information do you need? All right, so let's take a look at what we have here and what we know. We know that each bus holds 26 people. I'm not seeing any other numbers I can circle. So if they want to know how many buses will be needed, something's missing here. We know it can hold 26 people, but are we going to need 1 bus, 2 buses, 3 buses? We don't know, because we don't know how many people are going to the amusement park. So let's go ahead and write that out. No, we do not have enough information. We need to know how many total people are going to the park. All right, here we have 3 more problems. It's telling us for all 3 of these, we need to determine if the problem can be solved. If it cannot be solved, tell what information is missing. If it can be solved, solve it. So obviously, if we don't have enough information, we cannot solve it. So let's go ahead and look at this first one here. Richard is saving $5 a week to buy a bike. When will he have enough money? When? I don't have any information telling me, well, let's see. I do have information telling me $5 a week. So is that going to take him 1 week, 2 weeks, 3 weeks? Let's see. If he saved for 3 weeks, that would be $15. Is that enough for the bike? Oh, wait. We don't know how much the bike costs. So I'm going to go ahead and say we don't know the cost of the bike. All right. It's a pretty good indicator, I would say. If the problem only gives us 1 piece of numerical data, it is likely that we don't have enough information to solve. Let's take a look at our next one here. Natalie wants to find out how much her cat weighs. She picks him up and steps on the scale. Together, they weigh 94 pounds. How much does the cat weigh? This is a good strategy for Natalie to figure out what her cat weighs. If she knows together they weigh 94 pounds, if she is able to subtract her weight, she would get the weight of the cat. However, we don't know how much Natalie weighs. So again, I would write that and record that. For the last one here, Phyllis wants to make 8 pot holders. She needs 36 loops for each pot holder. So 8, 36 loops. How many loops does she need? Okay, so here I do have more than one piece of numerical data. So I should really consider, I probably have enough to solve this. Is it right? So 8 pot holders, 36 loops for each. That is my key word there. How many loops does she need for all of them? So I'm going to let you go ahead and solve that last one. And then you are off to practice.